Let's start. Hello everyone. Welcome to NEET World. So in this session we are going to see JEE Mains PYQs of Physics. So in previous class we have seen some questions in JEE Mains PYQs of Physics, right? So let's continue with the next part of the question in this session. So let's go on. And today's first question is, yes, this is the question of today's class. An electric dipole is placed at an angle 30 degree with an electric field intensity 2 into 10 power 5 Newton per coulomb. It experiences a torque equal to 4 Newton meter. The charge on the dipole, if the dipole length is 2 centimeter is, okay, I need to find what is the charge now. So what is the formula we have known, we know for the torque here, PE sin theta, right now. Let me write the formula first here. We know the formula that tau is equals to PE sin theta, right now. Yeah. Now what are the given things here? Theta is equals to 30 degree. Then electric field intensity E is equals to how much? 2 into 10 power 5. Then what else is given? Torque is given, tau is equals to 4. So I'll write this as Newton per coulomb and this is Newton meter. Okay, no? And length is given. Length is equals to 2 centimeter. Everything is in SI unit, and convert this 2 into 10 power minus 2 meter. Right? No? That's it. Now I need to find the charge. Okay. So from this equation we know that P is nothing but Q into L, right? Now write that equation. Tau is equals to QLE sin theta, right? Now sin theta. So what else is given? Theta, E, tau, L. So take everything in one side and Q in other side. Let me write Q is equals to tau divided by LE sin theta. So what is the value of tau? It is 4 and length is 2 into 10 power minus 2, right now? Yes. And the value of E is 2 into 10 power 5, 2 into 10 power 5, and sin 30 is 1 by 2, 1 by 2. That's it. So now this 4 and this 2 will get cancelled and this 2 will go to the numerator. 2 divided by 10 power minus 2 and 10 power 5 will become 10 power 3. So final answer will be 2 into 10 power minus 3, right? No? So what is the given? Yeah, it is charge, no? So it is coulomb and options are 8, 2, 5, 7. So it is, yeah, 2 millicoulomb. Answer is option 2. Is that fine? We'll go for the next problem. Okay. Can we go? Is that board visible now? For whoever watching in online? Okay, can we go for the next question? Yeah, thank you for confirmation, Sam. Okay, the next question is, suppose the charge of a proton and an electron differs slightly, one of them is minus E and other is E plus delta E. If the net electrostatic force and gravitational force between two hydrogen atoms placed at a distance d apart is 0, okay, then delta E is the order of. So they are asking the what is the order of the delta E value right now. So what is the thing here they have given, the distance d apart is 0, like equipotential, no. So I can take electric field equals to the gravitational field, no. Yes. So what is the formula we know for electric field? 1 by 4 pi epsilon naught, yeah, q in q1 q2 by r square, and gravitational field is g m1 m2 by d square or r square, whatever it is, and distance they have mentioned it is d. So take both d square only. So 1 by 4 pi epsilon naught. So q1 q2, no, like I will take both as e only. So delta E, no. So delta E the whole square divide by d square. This is for electric field, and gravitational field is nothing but g m1 m2, no. So both hydrogen atoms, so square mh square by d square. So this is the thing. From this I need to find what is delta E value. That's it. No, delta E value is there into 10 power something is there, no, 10 power something. I need to know what is the order of that. That's the thing they are asking right now. So from this we know 1 by 4 pi epsilon naught value is nothing but 9 into 10 power 9 right now. And what is the value of G? G is gravitational constant, right? It is 6.67 into 10 power minus 11. And what is the value of M? They have given 1.67 mh, mass of hydrogen atom is 1.67 into 10 power minus 27 kg. So these are the known things right now. From this I can use these values and I can get the value of delta E. So delta, I mean d square and d square gets cancelled out. So delta E whole square should be equals to g mh square into 1 by 4 pi epsilon naught, like 4 pi epsilon naught will go to the other side, 4 pi epsilon naught, right now. So this is the thing. So from this delta E will be equals to under root of g into mass of hydrogen atom into, I mean that square, no, into 4 pi epsilon naught. So from this, no, it is square, I can take the mass 1 outside. So 1 mass will come outside and remaining things g into 4 pi epsilon naught. Now substitute the values whatever they have given here. So we know 1 by 4 pi epsilon naught is nothing but 9 into 10 power 9. So what is the value of 4 pi epsilon naught? So 4 pi epsilon naught can be written as, so 4 pi epsilon naught can be written as 1 divided by 9 into 10 power 9. So no need to do any calculation for 9, 6.67, 1.67, no need. Only take that powers whatever there, okay, whatever there. So now do the calculation for only powers. So what is the power for mass? It is 10 power minus 27 and under root of, it is 10 power minus 11, okay, 10 power minus 11. And what is the value for this? 10 power 9, no, take to the numerator 10 power minus, yeah, 10 power minus 9. So into 10 power minus 9. So what is the value? 10 power minus 11, 10 power minus 9, it is 10 power minus 20. Yes, 10 power minus 27 under root of 10 power minus 10 power 2. I can write like this, na? So this 2 and this root will get cancelled off. The final answer will be approximately 10 power minus 37 I am getting. So what is the values here given? Minus 23, minus 37, minus 47, minus 20. So option B is the answer, right? Option B is the answer. So board brightness is high, decrease the brightness. Okay, okay, I'll decrease it. No issues. Is this fine now, Sam? I have decreased the brightness now. right now. Sonali Gopes. Yeah, thank you. Thank you for confirmation. Yeah. Okay, can we go for the next one? I guess you got the answer for this question, right? We'll go for the next one. So the next question is, yeah, a metal cube of a side 5 centimeter carries a charge 6 microcoulomb. The surface charge density is, okay, they are asking for the surface charge density. What is the formula we know for the surface charge density? Yes, it is sigma is equals to Q by A, right now. So sigma is equals to Q by A. So what is the given terms here first? Q is given, Q is equals to 6 microcoulomb, which is nothing but 6 into 10 power minus 6 coulomb, okay, and the side of the cube is given, L is equals to 5 centimeter, which is nothing but 5 into 10 power minus 2 meter. I need to take the area of the cube. So substitute the area of the cube here, and charge is given Q and A is given. So now do the calculation and give the answer for this question. We'll see. Whoever gives, we'll see. Yes, so trick is like here they have given the surface charge, don't take the area like a cube, you don't take 6a square, you should take, okay. The area is nothing but a is equals to 6, a square, no, like L I have taken, L square I will take, okay, okay na. So what is the value? 6 into 5 into 10 power minus 2 the whole square, where it is 25 into 10 power minus 4, right now. So what is 25 into 6? 25 into 4 is 100, into twice I should add, no, it is 150, right? Yes, 150 into 10 power minus 4, that's it. So I can take 10 and 10 here, so which is nothing but 15 into 10 power minus 3, right now. So the value will be 0.015, 0.015, that's it. So I know the value of A now, I know the value of Q now. So substitute the values. So 6 into 10 power minus 6 divided by 0.015. Now give the answer. I have given the next step also. Only the calculation is pending. So give the answer for the question, we'll see. Option 1. Once you check it, option 1 is that answer. Is that answer is option 1? See, if I take 6 divided by 0.015 and 10 power minus 6, so can I multiply with 10 power 3 and 10 power 3 down? 6, 1, 2, 3 divided by 15, right now? Right now, I will get 6000 by 15. So into 10 power minus 6, I will take this 2 zeros and this 4 will come, okay, here 4 will come. This is 1 times and this is 4 times, this is 4 times. So option 2 will not, option 1 will not come, no, I guess, yeah, option 3 is the answer. Yeah, you are correct, option 3 is the answer. 4 into 10 power minus 3 coulomb per meter square. Done. We'll go for the next question. Yeah, we'll go. We'll see the next question. The next question is, a hollow metal sphere of a radius r is uniformly charged. The electric field due to the sphere at a distance r from the center. Okay, so when I take the sphere now, which is of having electric field E, so the radius of a sphere is capital R will take. Suppose if I take a small r which is less than the capital R, no, capital R. So in that time electric field will be 0. When it goes out, yeah, I will write here. I will write the thing here and give me the answer, we will see which option is correct. So when I take R is less than capital R, so the sphere is there and radius of a sphere is R and which is having electric field E. Okay. So in this case electric field is 0, and when I take the case like R is very greater than R, capital R, no, in this case no, we know the formula, electric field na is inversely proportional, no, to R, inversely proportional. So what will happen? R increases, that small r increases, field decreases. So which option is correct? 0. We can eliminate option 1 and option 4. So out of option 2 and option 3, which of this correct? Decreases as r increases, increases as r increases. Which option is correct? So first one 0, that's it. As r increases it is 0. Then what about the second case? First case this is correct and this is correct. What about the second case? I told it is decreases na, so option 2 is the answer. Yeah, option 2 is the answer, Sam. Sorry for the glitch, I guess it's getting blur. I'll adjust that. Okay. Okay, we'll go for the next question. Yeah. So this is the question. Two parallel infinite line charge with linear charge density plus lambda coulomb per meter and minus lambda coulomb per meter are placed at a distance of 2r in free space. What is the electric field midway between the two line charges? So first we need to know what is the formula for the line charge. Can you say what is the formula for the line charge? Yeah, it's there in board also, like you can see and say also, no issues. Yeah, the same thing na, like lambda by 2 pi epsilon naught r. I will write the formula here, the line charge formula. E is equals to lambda by 2 pi epsilon naught r. Okay. Now what they told, like they are having plus lambda and minus lambda in the midway, no, in the midpoint na. So in the midpoint, in the sense I need to take into 2. So the answer will be 2 and 2 will get cancelled. Lambda by epsilon, I mean pi epsilon naught r. What is the answer here? Which of the option? Option 3 is the answer. That's it. Religious minds. Sir, can you teach in Hindi? I'll try, madam. I'll try my best. Like, I can understand somewhat Hindi, but we'll see. I can able to teach in Telugu also. Tamil also I can teach, but Hindi little bit. Okay. Either it can be he or she, I don't know. Yeah, we'll go for the next question. A spherical conductor of a radius 10 centimeter as a charge of 3.2 into 10 power minus 7 coulomb distributed uniformly. What is the magnitude of electric field at a point 15 centimeter from the center of the sphere, where 1 by 4 pi epsilon naught value is given 9 into 10 power 9 Newton meter square per coulomb square. Okay, so what I should do here, I need to know the formula for electric field, right? So kq by r square, kq1 q2 by r square, na? Yes. So here k is nothing but 1 by 4 pi epsilon naught, and charge is given 3.2 into 10 power minus 7, and r is given in terms of 10 centimeter. Okay, so I need to find it from the point 15 centimeter. So can you give answer for this question? We'll see. No need to do anything with the 10 centimeter, like I need the electric field, that's it, 15 centimeter, right, directly. Yeah, I'll write the formula also here. The thing is, what I should write here, E is equals to, yeah, the value is k, no, k is nothing but 1 by 4 pi epsilon naught. I'll write as it is, k 9 into 10 power 9, and what is the value of charge is given into 3.2 into 10 power minus 7, and divide by, I should convert it into meter, 15 into 10 power minus 2 meter. Okay, now you can do it easily. Yeah, it is square, na. So 15 into 10 power minus 2 the whole square, that's it. Give the answer for this question, we'll see. So what I should take here, 9 into 3.2 divided by 15 the whole square, I'll keep as it is. Now what it is, 10 power 9 into 10 power minus 7, so minus 7 divided by, it is 10 power minus 4 will come. Okay, do this calculation and give. So 9 into 10 3.2 divided by 225, no, 225. So this thing, the power thing is 10 power minus 4 will come to numerator, means 10 power 4 will come, 9 plus 4 is 13, 13 minus 7 is 6, so 10 power 6. Okay, and the thing, I need the value of this one now, only the value of 9 into 3.2 divided by 225. So if you get the value, we'll get the answer, that's it. So what is the answer? Which of the option is correct? Option 1, 2, 3, 4. 1.28 into 10 power 5, 1.28 into 10 power 6 into 10 power 7 or 10 power 4. Which of the option? 1.28 surely. Yeah, every option is 1.28. The only thing is I need to find which is the correct one, that's it. So option 1 is the answer. Option 1 is the answer. So can we go for the next question? Yeah, 0.128 na, 0.128, yeah. So 0.128 into 10 power 6, right? So when I multiply with 110, it will become 1.28 into 10 power 5, right? No, option 1. Yeah, Sam, that's correct answer. Option 1 is the answer. Fine. So we'll go for the next one. A charge particle having a drift velocity 7.5 into 10 power minus 4 meter per second in an electric field of 3 into 10 power minus 7 volt per meter as a mobility in meter square per volt square per second, meter square per volt second, that's it. Okay, I need to find what is the mobility formula. So mobility formula is nothing but mu is equals to drift velocity by electric field, na? I'll write the formula here. So mu is nothing but mobility, okay. So where mobility is nothing but drift velocity divided by electric field. Now substitute the values whatever they have given, that's it, and we'll get the answer. It is 7.5 into 10 power minus 4 divided by 3 into 10 power minus 10. Okay na? So here 7.5, no, 7.5 divided by 3 will get 2.5, right? 2.5. So this 1 times and this is 2 times will come. 2, 3 2s are 6, remaining 1, it is 5, 2.5. So 2.5 into 10 power minus 4 into 10 power 10 will come na, minus 10 will become 10. So 10 power minus 4 and 10 power 10 will come 2.5 into 10 power 6, okay na, which is in meter square per volt second. So 10 power 6, option is 1, 2.5 into 10 power 6. Can we see the next question? Yeah. So 2 point charges minus Q1 plus Q are placed at a distance L apart as, okay, a figure is not given, no, I will keep the figure, no issues. 78th question, I mean, okay, question number 8, okay. I will give the figure here. So 2 point charges. So one is plus Q charge is there and one is minus Q charge is there. They are kept apart of a distance L. Okay, this is the figure. The magnitude of electric field intensity at a distance R, where R is greater than L, where is S. So when we talk about the point charge and the electric field intensity, right? So it is obviously it is greater than L, no, greater than L. So it answer will be E is inversely proportional to R cube. That's it. Directly can say by closing eyes, is inversely proportional to R cube. Option is 1. Okay, can we go for the next question? Fine, right? The angle between the electric field line force of the force and the equipotential surface is, okay. Can you give the answer? Like it's only definition, I guess. Like electric field lines, no. Electric field lines are perpendicular to, yes, perpendicular to the equipotential surface, right? So what is the work done? What will be the work done? It is 0. So whenever we talk about the work done and the angle is perpendicular, so perpendicular in the sense option B, that is 90 degree, right? 90 degree. So 90 degree in the sense whenever we talk about the 90 degree and work done is 0. That's it. So angle between electric field force and the equipotential surface is always is 0 for the work done. I am saying for the work done case. So it's by the definitions, okay. Sam, which one you are saying? W and 2 for this question? Okay, I hope you got na. We'll see the next question. So next question is, an electric dipole is placed at an angle 30 degree with an electric field, okay, electric field intensity 2 into 10 power 5, it experiences a torque 4 Newton meter. Calculate the magnitude of a charge on the dipole, its dipole length is 2 centimeter. Like same kind of question we have seen in the starting, no, right na, same kind of question in the starting also. So what is the formula we should use now? Torque is there and electric dipole is there which is at an angle theta, 30 degree is there, intensity they have given. So tau is equals to P E sin theta theta, where I need to find the charge on the dipole. So P will be equals to Q into L. So L is given as 2 centimeter, convert it into meter, 2 into 10 power minus 2 meter. Now substitute the values whatever they have given. So I need to find Q now. Q I will keep one side, remaining term other side, right now. I will write here. So tau is equals to QLE sin theta, where Q is nothing but tau divided by LE sin theta. So what is tau here? 4, and length is 0.02, no, 0.02 into, I will write only 2, 2 into 10 power minus 2 only, 2 into 10 power minus 2. Electric field is, electric field intensity 2 into 10 power 5. What was the angle? 30 degree. Sin 30 is 1 by 2. Yeah, same kind of question I guess. 4 and this 2 will get cancelled off. This 2 will go upside. 10 power minus 2 and 10 power 5 will become 10 power 3. So the final answer will be 2 into 10 power minus 3. That's it. Option 3 is the answer. 2 millicoulomb. Yeah, Sam, you gave the right answer. Yeah. Option 3 is the answer. 2 millicoulomb is the answer. So with this we'll end this session. So we'll bring some more questions in the next session, okay. So don't try to miss the sessions. So it is more helpful for the students who are going to appear for JEE Mains 2026, okay. So we'll see different kind of questions and different kinds of formula in each questions, okay. So try to note the formula and what kind of formula are applying in the questions and how that formula has been applied in that each part of the question we'll see, okay. So thank you guys, until then we'll see in next class. Bye bye.